Hey everybody, it's Mr. Han here. Here are our notes on solving, or not solving, squaring and square rooting. So today we're going to be looking at what does it mean to take the square root of something. Before we get to that, we are going to talk about what is a perfect square. Okay, and so a perfect square is, well, we talked about exponents recently, and so a perfect square is going to be when we square something, a number, a whole number, right? Um, and so squaring is when we take it to the power of 2. So here you can see that there are a couple of examples. All right, so what is a perfect square? The result of squaring a whole number. Now, if you're not sure what a whole number is, okay, it's a number that is not a fraction or a decimal. So numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, whatever, right? These numbers are all whole numbers, and they're not a fraction. They're not a part of a number. If I take 1.5, that's not a whole number. So here we're going to take whole numbers and we're going to be squaring them. Okay, so squaring is when we take it to the power of 2, to the second power. So we could say something like this, x squared. Okay, so anything to the second power is going to be squared. So here, our first number is 2 squared. What's our base? We have 2, and our exponent is always going to be 2 when we are squaring. So here's our x squared. Here we have 2 times 2, which is 4. So 2 squared is 4. So the perfect square is 4. 3 squared, our base here is 3. Our exponent is 2, because squaring means we're taking it to the second power. 3 times 3 is 9. 4 squared. 4 square. Ever played that game? No. Okay. 4 times 4, and we have 16. So all these numbers are perfect squares. 4, 9, 16. The next perfect square would be 5 times 5. And so we are going to go ahead and look at this table and fill it out. All right. So base is 1. So 1 squared is going to be 1 times 1, which is 1. 2 squared, 2 times 2, 4. 3 squared, 9. 4 squared, 16. So we're just multiplying the number, the base, by itself twice. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared is 100. 11 squared is 121. 12 squared is 124. Wait, 164. What am I saying? Wait, 12 times 12, 144. 144. Thank you. So, we should know up to 12 squared, okay, because we know our math facts. If we know our multiplication table, which is up there, okay, we're just going down the middle and we are multiplying 12 times 12, 1 times 1, 2 times 2. So we should know up to 12 squared. All right. Now, what I want you to do is I want you to draw a line right here after 15 squared, because I would like you to memorize up to this point. So I'll make this a little bit thicker. So I would like you to know up to 15 squared. I won't tell you what the rest are, but I'd like you to memorize up to 15 squared. So let's go ahead and keep writing down what the perfect squares are. 169, 196, and 225. So these are numbers that I think you can memorize. 169 and then 96, the numbers just get flip-flopped. So that should help you memorize these two. And then 225 is not a hard number to memorize. Okay, so let's go ahead and keep writing down on this list. We have 16 squared. That is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And sorry about all those text messages. It's Mr. Takaya and Mr. Galindo. I'm actually going to mute this. How do I turn this off? Shush. Shush. I don't know where the do not disturb mode is. I'm just going to mute this computer. All right. And then 20 squared is 400. So hopefully me trying to mute the computer gave you enough time to write this down. All right. So those are the list of perfect squares when we take a whole number and we multiply it by itself. 2 times 2, 3 times 3, 4 times 4, 5 times 5, so on and so forth. Okay? Now that we have perfect squares, the opposite of squaring is what we call the square root. Now, some of you might have seen this before. It's like a division sign, but it has a little caret, what we call this little lip right here. Okay? So here, the opposite of square root is called the opposite of squaring is called square root. Oh, that's a horrible line. Let's go ahead and try that again. Okay? So here, it's like the inverse operation. If you think of multiplication, what's the opposite? What's the inverse operation of multiplication? Right? Hopefully you know it's division. And what's the inverse operation of subtraction? It's addition. So here it's kind of one of those things where they undo each other. So the opposite, or we could say inverse operation. And I don't think it's actually called an inverse operation here, but it's the idea, okay? Operation. So think of it as inverse operations. So squaring, the opposite is square rooting, okay? So let's look at this. 6 squared, what's the base here, right? 6 is the base, and we are squaring it. We're raising it to the second power. So here, when we have 6 squared is 36, then the square root of 36 is going to be whatever the base is, right? It's the opposite of the square, so it's going to be 6. So the base here is 6, all right? So here I want you to think of it like 6 squared is 36, then the square root is 6, all right? Here's another one. I think you can answer this. Since 15 squared is 225, right? What's the base? 15. The exponent is 2, right? Then the square root of 225 is 15. All right. Now, sometimes people are going to say that the square root of 225 is positive 15 or negative 15. So it's also said to be a plus minus sign. I'm going to go ahead and highlight this. I'll highlight it in purple. So it means plus or minus. Okay. So we're only going to focus on the positives here, but that's another way to look at it. So let's do a couple examples. Squaring and square rooting undo each other. They undo each other, okay? What does that mean? Think of it as inverse operations. So I'm going to give you a couple examples where they undo each other. The square root of 15 squared. Well, if we have the square root and we have a squared, those two are going to cancel each other out. They're going to undo each other, and we're left with 15. All right? Here is another example. The square root of 4 squared. Oh no, the square root of 4, all raised to the second power. Okay? And so here, we'll think of it as square root of 4 times the square root of 4, which is square root of 16, and that gets us 4. Now, instead of writing all this out, I want you to be able to recognize that the square root and the squaring cancel each other out, and what are we left with? We're left with 4. Okay? Here, let's go over another example. The square root of 49 squared. This is the same thing as saying 49 times 49, right? And so here we can cancel these two out and we get 49. So it's undoing each other. It's the opposite, inverse operations. Okay, last example, square root of 11 squared. Well, squared and a squared and a square root undo each other, so we're ending up with 11. Okay? All right. Let's go ahead and take a look at some practice problems. The square root of 25, this is 5 times 5. So this is the square root of 5 squared. We could think of it like that, and they cancel each other out. 5. But this is a perfect square. We could go ahead and take a look at this list. 25, the answer is 5. Here's 16. Let's keep a look at the list. Keep the list here. We have 16. So here, the answer here is 4. All right. Next. Ooh, this one looks a little bit tricky, but it's not. All we're going to do is we're going to put it as a fraction. Square root of 81 over the square root of 100. Okay. And so the square root of 81, that's a perfect square. It's 9 over the square root of 100 is 10. If you don't believe me, here you are. 81 is 9 times 9. 100 is 10 times 10. Okay? So knowing this list is helpful. If you know your math facts, you should know what the square root of 9 is and the square root of 4. So square root of 4 is going to be 2 times 2. So that's a perfect square. 9 is a perfect square as well. 3 times 3. Okay? Okie dokie. Now, here's another one. 400, it's on our list, right? We can see that 400 is a perfect square. So if we square root that, we're going to end up with the base, which is 20 here. So here, this is square root of 20 times the square root of 20. So here the answer is 20. Okay? Another way I could do this, stick with me. I could break up 400 to 2 perfect squares. Another way I could break this up is the square root of 4 times the square root of 100. The square root of 4 is 2, and the square root of 100 is 10. And then I can multiply this out, and I get 20. Okay? So that works as well. You can break them up. Here, we're going to break this one up. 64 and 100. The square root of 64 is 8, and the square root of 100 is 10. 8 times 10 is 80. So that's an easy way to do this. Break this up into numbers that we can take the square root of. All right. These are a little bit trickier here. We have some decimals. You can see that the decimal moves over 2 times. 1, 2. So if we want to move it over 2 times, if we're multiplying the same number, we're going to move the decimal over 1 time. So now just think, 36, is that a perfect square? Yes, right? We know that 6 times 6 equals 36. But because we want to move the decimal point over 2 times, we're going to have to move it over once on each of these. So this is 0.6. All right? If you aren't good at multiplying and dividing decimals, that's going to be tricky. Okay? Here, 169. Think of the whole number, right? 169. We could break 169 is in here. It's 13 times 13. Right? 169. So here we're going to have 13. 13 times 13. But because the decimal point moves over 2 times, we're going to do the same thing. We're going to move it over once in each one. So we're going to get 1.3. All right. Okay, we're almost done. We got a couple more. Number 9 and number 10. Look at these two right here, right? They look very similar, but they're different. In the first one, right, you can notice that they're both under the same square root. And in number 10, they're split. Now, if they're under the same square root, we're going to have to solve underneath the square root first. So what is 5 squared? 25. What is 12 squared? 144. And now we're actually going to add those two together. 25 plus 144 is 169. And the square root of 169 is a whole number. That is 13. All right, here. Square root of 5 squared, well, it's that concept, right? They cancel each other out. 12 squared, they cancel each other out. 5 plus 12 equals 17. Notice that the answers are different. They are different because the problem is literally different. Okay? Number 11. You're going to see problems like this in high school. Here you have 4 square root of 196. You can think of this as 4 times the square root of 196. And the square root of 196 is 14. If you don't believe me, I memorized these. 196 is 14 squared, so the base is 14. 4 times 14 equals 56. That's our answer. Next, we have the square root of 8 times the square root of 8. Now, the fun thing with square roots is if you find a pair, that means 8 times 8 is going to be multiplied. The base is going to be, you could think of this as 8 squared. And the base is 8, so the answer here is 8. If you ever have 2 square roots and the number is the same, you can think of it as the number is coming out. Right? It's coming out of the square root. So the whole number is 8. Last one on our notes, and I am moving pretty quickly, so you can pause whenever you want. Here the area is 49 meters squared. Well, how do you find the area? It's base times height. If this is a square, the numbers have to be the same. So the square root of 49 is 7. So that tells us that we have 7 meters and 7 meters. So how long is each side? 7 meters long. That's our answer here. Okay. Now, these are our notes for square rooting. Okay, it's an introduction to square rooting. You already kind of knew what squaring is because we talked about exponents. It's to the second power. All right?
Pardon the interruption.
No. Sorry. If you have any questions, let me know. Scale of 1 to 5.